Alright, Common Core Algebra 1, so here we are for our first lesson with this new chapter. This is all going to be all about linear systems of equations. And by the end of this lesson, you will be able to identify a system of equations, check to see if a point is a solution, and then also going beyond that, you'll be able to identify the solution after graphing both lines. So a little bit of review before we do that. If I go ahead and plot this first line, so we're going to need to remember that, which both of these are in y equals mx plus b form. If I plot that first one, our b is 3, which means I have a y-intercept at 3, and then my slope, remember the number in front of x is 1, so negative 1 over 1. So I'm going to go down 1, right 1, and then I'm going to draw a line through those 2 points. Like that. Now it's going to be really important in this chapter that we draw our lines pretty long because we need to make sure that we can see where they intersect. Okay, so on the second one now, so I've done the line in red. Second one, my y-intercept is 1, so I'm going to put that point right there. Again, number in front of x is 1, so my slope is 1 over 1. So I go up 1, right 1, put a point, and then I'm going to need to draw this line. And I'm going to do that by making sure to go through both of those points. Okay? And so this would be our 2 lines. We graphed one in red, we graphed one in blue. Big thing, remember B is your y-intercept, and you're going to do this first, and M is your slope, and you do this second. Okay, so first is y-intercept, second is slope. That's how we're going to graph line. That gives us 2 points. That's from last semester. So the next thing then is we have some definitions. So a definition of a system of linear equations is 2 or more equations with the same variable, and so that's important. They're going to have the same variable. For our sake, we're going to use x and y. A solution to a system of equations is an ordered pair or point that make both equations true. So that's the important piece here. It makes both equations true. And when we talk about an ordered pair, we mean a point where we have an x value and a y value. And then the last one, to check a solution, essentially what you're going to do is just take that ordered pair that you're given, the x, y values, and test to see is this statement true. And that's the important piece. If it's true, then it is a solution. And if it's not true, then it's not a solution. So for this example, we have 2 equations. We're going to check both these points. So the first one we're going to do is negative 3, 4. So I'm going to take it in. I need to do it in both equations, don't forget. So I'm going to take that first equation. I'm going to change my y to 4. So I'm going to do this one in red. Y to 4. And we have a negative of a negative 3 for x. Plus 3. So I get 4 on this side. Negative 3 is just 3 plus 3 is 6. So already, right there, we know this one is not a solution. Now, it could have worked for this one. If it worked for this one, we'd need to plug into the second one as well. But since it didn't, we don't need to. Now we're going to try over here. Our second one, points 1, 2. So I'm going to plug in, again, that first equation. 2 for y. Now I'm going to have a negative 1 plus 3. And when I simplify, negative 1 plus 3 is 2, so that works. But we're not done now because we still need to check the second equation. So I'm going to use blue for that. Same coordinates. 1, 2. I want to plug in those. So I've got 2 for y still, 1 for x plus 1. And if we simplify, 1 plus 1 is 2, so that works. Since it's true for both of these, 1, 2 is a solution to that system. Negative 3, 4 would not be. So negative 3, 4 didn't work because it didn't work for that one equation. 1, 2 works for both. So it is a true statement. So therefore that is a solution to this system of equations. And now 3 other important key terms are going to be consistent, independent, or really we're just going to say independent, dependent, and inconsistent. If something is a consistent independent solution, it means that there are two distinct lines, there is one intersection, and therefore one solution. So it will have a solution. Independent system, one solution. A dependent system means when you graph a line, they'd be right over top of the other one, and so therefore you have infinite solutions. So dependent system, infinite solutions. And finally, an inconsistent system happens when we have parallel lines, and they never intersect, therefore there are no solutions. Okay, so independent, one solution. Dependent, infinite solutions because they overlap each other. Inconsistent, no solutions because they never intersect. Hey, with that said, in order to solve by graphing, so here, these are really important notes for today. In order to solve by graphing, first thing you're going to do is graph both equations, so two lines. So you might want to add that note in. We're going to have two lines that we graphed. Okay, next piece, after we graph those two lines, we're going to find the point of intersection, and most importantly, identify the coordinates at that point of intersection. And then finally, we're going to check your solution by plugging into either equation. Okay, identifying the coordinates, this is your solution. And those numbers are what you're going to check. Those numbers are what you're going to plug in to either, and really we should say, both equations. So let's change this into both equations, because remember it has to be a true statement for both of them in order to be a solution. Okay, now the point of intersection that we just mentioned is the point or coordinates where the two lines cross or intersect, and it's always going to be the solution. It is a set of x and a set of y. So this is going to have an x and a y coordinate. Remember, x needs to come before y. Okay, so if we try one here, we already graphed these two lines. We did this earlier. And here you'll see where the two lines cross is right there. So the point of intersection has coordinates 1 for x, 2 for, excuse me, 2 for y. And so our point of intersection or solution is 1, 2. And if we plugged it in, we'd have 2 equals a -1 plus 3. Which simplifies to 2 equals 2, so it works on that first one. And then if we plug it in the second one, we'd have 2 equals 1 plus 1 by plugging those in, which gives us 2 equals 2, and it works there. So it works on both equations, so we know that that is, in fact, a solution to that system. Okay, so that is how we solve a linear system by graphing lines. Big thing here is your point of intersection. You're going to graph both lines just like we did last semester. Find your b value, plot that point, use your slope to get the second point. Do that again for the second line, and then wherever they intersect. So you could have an independent system where they intersect once, a dependent system where they intersect an infinite amount of times, or an inconsistent system where they never intersect because the lines are parallel and therefore there are 0 solutions. Alright, all that is big stuff. We will see you next time.